Okay, hi. Um,
From
okay, we're already live on YouTube right now, and uh, okay. So before we start, I would want to have an introduction for Seku and Hansen first. So my first word will be that. So my name is Carol, and I will be the host to support for the training workshop day 5 today. With the topic of turning up the building TFs with Rush on Change. So the purpose is of the online workshops during these days to support further developers communities in Vietnam in order to help them support them to have more insight and also knowledge about ZKP brushed language, because we also hosting a hackathon, the Vietnam Rush Hackathon in next week in June in the GM conference. So yeah, your presence here is really such a supportive for the developers communities in Vietnam and so on to have more insight, have more knowledge, and more understandable about this field. Okay, so I will be back to introduce you guys first. So hi Hanson's and so we have our speaker here. So we have Hansen Zhang, who is also the of the mentors and the judges for the Vietnam Rust Hackathon, and also the DAFRO software engineer representative from CKB Eco Fund. And also we have Saku here. He's also a DAFRO advocate and a representative from CKP Eco Fund, and also will be the judges for the Vietnam Rust Hackathon also. So Hansen, can you take turn to introduce about you and like more information about you?
Okay, cool. As you said, I'm from the CKP co-found Stereo team, and I'm here to introduce you guys about how to develop CKP contract on the CKP chain today.
Okay, cool. How about you, Saku?
Hello everyone, good evening. I'm Saku from CKB EcoFund and also a debris advocate. If you have any question about the GM Vietnam Hackathon's CKB's track, or you need more developer resource about the CKB and the Rust, you can just leave the comments to me and I will reply you instantly. And today I will, if you have any question about the speech today, you can leave your questions in the comments and I will answer the question in the comments, or Hanson will also answer your questions. Okay, thanks for the invitation. Thanks, Carol.
Thank you for your introduction. It's really brief and very informative also. And so I won't let the audiences to wait any longer. So I will be back. I will back to Hanson's for her speech, which is will be mainly about for the mentoring and also like programming issue for the ZKP and with Rush for the developers. So back to you, Hanson's. You can have your stage now.
Okay, cool. Let's start now. Great. Okay, before we dive into the world of development, I want to introduce the CKB first. Right, CKB is a public chain. It has been running for over 4 years. So today we are going to talk about how to develop some program on the CKB chain, how to build your own like smart contract or script on the blockchain to control your assets or like issuing your assets. Great. As you can see, CKB is now currently in the BTC ecosystem. So in the Bitcoin ecosystem, you might heard about the UTXO, the unspent transaction outpoint, like this kind of model. But in the CKB ecosystem, we usually talk about the sale model, right? The CKB system itself is based on the sale model. It's kind of pretty similar to functional programming. The idea, the concept is similar to functional programming, right? You have some data and you have some process, you have some function to transform your data. So, okay, before we actually start developing, let's talk more about the cell model. Great. If you have heard about the UTXO before, you might be quite sounds familiar to you about the cell model. In the CKP cell model, we don't have some kind of unspent things, unspent output. Instead, we introduce a new concept. It's about the cell. If a cell is involved in a transaction, it's called spent or it's called dead. You can think about that a cell is similar to some data in the Rust. And if it's moved, you can't use it anymore because it moved and it transformed to other kinds of data in other place in the memory. So you can think about that a dead cell is kind of moved data, moved variable in the Rust. And a live cell is the things that you have ownership in the Rust programming language. And the process of transaction is some kind of like you move it to a function and the transaction help you to manipulate the data inside the cell and it produces a new cell to corresponding to, I mean, like how your transaction want to do with it. So similar to the Bitcoin transaction, the CKP transaction not computes the result. It only verifies if the output, the user provided the output correct to the input it gives. For example, we can see here we have a verifier. The verifier verifies that the content in the transaction, the output should add 1 to the input. So that's the whole process. We call this should add 1 thing a verifier. And it verifies the whole transaction to make sure that the data output is corresponds to its input. Well, it's quite simple here. Like every transaction, the data inside the cell as 1. So this kind of thing is just like the type theory in the Rust, right? As you can see, this kind of verifier, the should add 1 verifier, we describe its behavior, and we can give it a new name like transactions counter. And we said this kind of cell we have, it belongs to this type. All these cells are transaction counters. And every time they involve into a transaction, their inner data will add 1 to corresponding to the transaction they experience. Great. So what we are going to talk about today is some SUDT type. SUDT type like is called simple user defined token. You might heard about the token like non-fungible token on the Ethereum or something. It means some kind of data and you own some money, you own some US dollar in your account and it's a number. You can transfer your money to others. You can transfer my token to others and you can also burn your token and like you just don't want it. So if you are an owner, you can also mint some token. You can create some token from nothing because you need to issue some token. So this SUDT type we are going to talk about today only around 3 operations. One is minting. Minting means you create some token from nothing, and it can only performed by an owner of this SUDT type. And also, it can do it around transferring. Transferring means you can transfer your token to others. So it can perform by anyone. And the last thing is burning. Burning means you can reduce the amount of token you own. So it can also perform by anyone. Cool. This is a quick introduction about the CKP script and the cell model. I hope everybody knows follows me. Great. And now I'm gonna present my screen. Great. Great. I hope everybody can see my screen. And now we are gonna start do some coding things. So before everything, let's create a project for SUDT. Yeah, like this. We have a tool called Capsule. Capsule is built for CKB contract development, and it's kind of easy tools help you to build a new project and to compile things inside the CKB ecosystem. So we have and like this. So this is the file structure of our new project. As you can see, we have some tests and a contract library to store our source file. Okay, this is the entrance of the CKB contract. And it's pretty simple, right? It do some initialization, like do some memory allocation things for the non-STD environment because it runs on a REST 5 virtual machine on the blockchain. So it's not in a standard REST development environment. It's in the non-STD environment. So we have this kind of things here. So the program entry will returns the I8 integer, and it means the error code. If it's 0, then your program is success, and if it's not, it encounters some problems. So this is the entry, and we can see our main logic here. In this file, we have a main function, and we can do things inside. So as you can see, we have some system codes here like load script and load transaction hash or this kind of thing. And we are gonna, everything we need to involve today is about, I just talked about before. So it's about the script, like the type script. So we are implementing the SUDT type script today. So we are gonna load the type script and load its args. So let me do some main logic. So as we said before, we need to check about is transferring, is burning, or is minting. So we were gonna have a function called collect amounts because a transaction involves to the input cells and the output cells, and all input cells and all output cells have its amount. So we need a function to calculate its amount. Let's call the function collect amounts. And it will have a source. That means it's from input or it's from output. It returns a result, and the result, if it's success, it will be an integer, 128 bits integer. If it's not, it returns some error. So, okay. We will have a place to store how many amounts we currently have, and we will have a place for buffer to read the cell data. So in case it's 128 bits, it will have 16 bytes. So for each cells in the source, like input, first we load the data. Load the data in the index, and from the source, if we got some data, then just return the data. And if we make some problem like system error, if it's index outbound, that means we have reached the end of this source. So there is nothing more. We can just break this loop. If it's other error, we'll return the error. Right? And then we will check if the data has the same has our expected length existing. If not, we'll return error. So if existing, we copy all data inside the data because the data itself is a vector. And if we want to encode the data into a number, we need to copy it to a array first, or slice if you want. Yes. And we can decode it, the amount plus decode data to an integer. At the end, let's return the result. Cool. This is the function for us to collect inputs. It first loads cell data from the source, and from the beginning to the end, it loads every cell data and accumulates their amounts to a result and returns it. It's simple. So if we want to check about if we are transferring or burning, then first we will have an input amount, like the input amount involved to this transaction. We have collect amounts and source group input. You can think about the group input as the input. It goes to this script. It goes to this SUDT script. If it is input, it means every cells in the input, but it's not we are talking about today. So we just collect all amount from the group input. And we also have outputs amount. The source will be group outputs. And we need to check if the input amount is less than output amount. So if you are transferring, the input amount should equals to the output amount, right? You are not changing the total amount of the token. If you are burning, then your input amount should be larger than the output amount, because some token disappeared. We're going to define a new error type called insufficient amount. Right. You can just ignore this. Okay, this is a simple script, helps you to check if the transaction is transferring or burning your token. Cool. The next the next part we are going to talk about is how to mint your token. Because here is for everyone to perform the action. Like, and it's not checking who is doing this action. It's just like everyone can transfer and everyone can burn their token. So we're gonna do our next function is called, if you are an owner, you can mint some token. So we will do the check owner mode. It accepts the script arguments, it applies, and returns to if it's in the owner mode. So we're basically gonna do the same thing, but this time we're gonna load the log hash. Log hash is like the script hash, is the owner's hash of the input cells. We are not going to talk about the log script today, so I just quickly ignore this part. I load every owner information from the input, and similar to what we done below. If we got hash, then we just return the hash. If it's all found, we break. If we encounter some error, we just return the error. And we'll check if the args has it is the same with the hash. Okay, here if we found a cell with the same owner we configure to the script, we return true. And if it's not, we can't find such things, we return false. So the check owner checks every cell in the input and see if the owner involves to this transaction. If yes, then we can just skip checking, right? Because owner can do anything to your token. So if it's owner, we just return OK. Right. Let's do something else. And this will be our full SUDT TypeScript. Let's check everything. If it's OK. Yes, great. So this is main logic. First, we check the owner mode. If we are in the owner mode, we just stop doing other verification, like owner can do anything. If we are not in the owner mode, we will first calculate the input amount, and then we calculate the output amount and compare them if the input amount is less or equal to the output amount. If the input amount is less to the output amount, we will throw an arrow. And if it's not, like it's equals to the input amount is equals to or bigger than the output amount, we just return OK. This transaction is a valid transaction. So let's compile our contract. Let's use capsule build. Yeah, the capsule runs the compiler inside the Docker to make sure that every time you compile the same source code, you always got the same result. Cool, let's see. As you can see, yes, you can see we got some outputs here. Yeah, we got SUDT tokens here. It's a rectified program and can be run on the on-chain virtual machine, but it's just a constraint. Now we're going to write some tests for it to make sure it's running. Right? Okay, this is a simple example of how to test your program, right? This is kind of test success. And at first, if you roll the binary we just compiled by your contract, and the binary will be deployed on chain, deploy cell, like we just said, the verifier. This script will be deployed as the verifier. Then we will build a script to point to the verifier to attach it to the cell we have. Okay, this is the input cell, input out point. So the input out point points to an existing cell. And this existing cell will be involved into the transaction and it will create two out points. Two out points which have some other things and some has its own log script and has its capacity. And we are going to ignore these things today because we are mainly talking about SUDT today. So let's delete these things and do a quick introduction. So we are gonna have four tests. One is called test transfer. So first we need to prepare our environments, like build a transaction and inject some data inside the transaction. So we will have a function called prepare transaction, and we provide them input amounts. It's a vector, so you can have multiple inputs and output amounts, also a vector. And you can have a flag to tell if you are the owner. It returns a context, which like the chain, to store everything like sales, and returns you a transaction. Context. Let's create a mutable context first on default. For the log script, for the owner script, we use a script called always success, so that we can ignore this part today. For cell is always success. Yeah, this now always says that basically ignore everything, right? Every time you just pass the verification. Then we're gonna have two owners or users. One is called Alice. Useful from our always success outpoint, and it have an arcs. And one bias is 0. Expecting it will always success. And then we have sorry. Yeah, the status log, and we will have a pop log, which is actually the same as the status log, but with different arguments to distinguish them to the script. And we will create the cell depth. Cell depth is kind of things to help the transaction to find out where the verifier is. And it's not important today, so I just quickly skip it. Excellent. We have two player or user or wallets or log or owner. Anything you want to call it. And then we load SUDT script. This bytes. And we have a loader to load from binary. And we just compile all the SUDT contract. So we load the SUDT contract from our file system. This loader helps you to do this kind of thing. And then we should deploy the SUDT binary on chain. So the context deploy cell. Same as the always success. We deploy the SUDT binary. And we have a SUDT script to help cells to reference our SUDT type script. Our point is SUDT on point. And the arguments, as we talked about before, it will be the owner's log hash, the hash of owner's information. So this is called for calculating the owner's hash. Calculate script hash is bytes. And it's value always success. And this is our simple user-defined token type script. So same as before, we need to create a cell depth for SUDT. The endpoint is replaced with the SUDT endpoint. Great. And then let's build the inputs. The inputs are all cells. So inputs will be from our input amounts. Our input amounts, and we create interactor on it. And map for every amount, we create a cell for it. So first, let's create a cell. A cell, it has capacity. Capacity is some kind of special things on the ZKP to avoid state explosion, but we are not going to talk about it today. So it's just a fixed number. And its type script is SUDT. It's our SUDT script. And it has a log script. If we are in owner mode, its log script will be Alice log. Because we just use the Alice log as the owner. So if we are in owner mode, we will use Alice log as our input. If not, we will use Bob log as our input. And we're gonna build a cell. Great. And we can collect this iterator into a vector. Great. So this kind of cell should be deployed on chain to be an outpoint. So we kind of similar to our contract. We need to be deployed on chain by create cell. So the data, the cell data, the data stored inside the cell will be our amount in little and into bytes. And we will return a cell input. Great. Then we will have a cell inputs vector. After that, let's prepare our outputs. It's pretty much the same as the inputs. We're gonna create an array for our outputs. So for every output amount, we have a cell output. It has a TypeScript. It has the same TypeScript as the SUDT, and the log will be Bob's log because we are transferring our token to Bob. Great, that's it. Yeah, we build our cell outputs. And also we will have an array for output data. For output data, it's quite similar to before. So its content will be some bytes, amounts, we will collect them into a vector. Unpack it. Great. We have prepared everything we need. The log script, the TypeScript, the inputs and outputs. So at the end, we are going to create a transaction. So we will return the transaction equals to transaction. You can build a transaction from a transaction builder. From default one, and add the cell depths. We have two cell depths. One is log depth, and another one is SUDT depth. And we have our inputs. And we have our outputs. And output data. And build the transaction. At the end, we return the context and the transaction. Great. This is how we prepare our transaction. Great. Then we can write our first test. I'll just copy some code. So basically, we use the function we just wrote and prepare a transaction with 1,000 input and 500 outputs instead transferring and install in the owner mode. And we will complete the transaction and verify it. So let's run the test. And now it's compiling. We can write the burning test and the making test. Now the burning test will be you have 1,000, but your output is only 500. So it should also be success. And for the maintain test, you will have 0 inputs and you have 1,000 outputs. So if you are not in the owner mode, it should fail. So let's check. It should fail. We got a helper to assert the script if there is an error. The auto is fine. Great. And we can also, this one is you are not in the owner mode and you are trying to mint not owner. And if you are in the owner mode, you are expecting it will be success. So that's minting. You are in the owner mode and you need 1000 or from 0, and it should be success. Right. That's all 4 tests we need today. Good. We can run the transaction with the capsule, and as you can see, all four tests passed. Great. And this is how we implement an SUDT type script on the CKB chain. And considering the time, I think that's all we have today. And in the next session, we are going to talk about how to deploy the contract onto the CKB testnet and how you interact with your TypeScript on a website like a dapp, use your wallet or something. Okay, I saw the comments and somebody asking what the role does type theory play in the cell model of CKB. So as you can see, we just wrote a script called SUDT type. So can we back to my slide? Hello, Carol?
Hey, you need to back to.
Yes, slide.
You can just share screen normally.
Oh, good. Okay.
Like share again for the slide your screen.
It's not on the stage. Can you please move my slide to the stage?
Yeah, then just need. Maybe just wait a bit because normally we will just share slide normally. Okay, there you go.
So as you can see here, we have a verifier, which is our TypeScript, and this TypeScript controls the behavior of the data. So that's basically what type theory do. The type theory use constraints, the type, to control the behavior of your data. So if we have a transaction counter type here, then the data it controls can only like add 1 during every transaction. If it's an integer type, then it can like add each other and compare with each other. It controls the behavior of your data. It's not any arbitrary type of data like bytes. So that's what we do today. We implement an SUDT type. Like we have a token type. The token type allows you to mint a token and transferring a token and burning a token. This 3 action is what this type of cells or this type of data can do. Right. Any other program? Any other programs?
So actually, this is not transferring from wallet to wallet, right? It is like a new UTXO, right?
Uh, you can say like this first, this input cell is controlled by a wallet and the output cell is controlled by other wallets. So it's also transferred from one wallet to other wallet. It depends on its owner, the owner
So
of the
like
cell. Yes.
So like if I want to transfer you like $1, like I should I should transfer you like a whole wallet.
You should transfer the wholesale to others,
So
right? The wholesale containing the data to others. But in your wallet, you can have multiple cells like the UTXOs.
yes, got it. Um, so like for the minting, it's like one cell and it will create a new cell. For example, like in the slide, there's 10 stablecoin in this cell for the minting, right? And the
Yes,
transferring will be like 10 stablecoin to like two other cells,
yeah,
like a
to other
new.
cells, like you transfer $5 to others, then you transfer cell containing five to others, and you keep five to yourself.
And for the burning is like to delete the old cell, right?
Yes, it's just reduce the amount you have.
Okay, okay, got that. Okay, okay, okay. And may I ask, like, this type of this type of I mean, like this type of SUDT, is this any kind of relevance to the like all the code that you just sharing? Like, how can we relate this one to the slide that you just shared from above?
You mean the previous slide we just showed,
I
like this one?
like I mean like all the coding that you have just shared earlier.
Yeah,
There's
the coding we just do is basically implement the SUDT. Right, we just have an SUDT type on the CKB chain, and it controls what the transaction can do. Prevent the inflation of stablecoins last year. Well, the SUDT is kind of help you to create a stable coins, right? And it's not about the economic models. It's just simply like some script on the CKB chain.
Yeah, SUDT is like a framework to help you develop the stablecoin. So if you want to issue a stablecoin on CKB, you can just use the SUDT as the reference, or you want to issue other tokens, you can also use this framework as the reference. But if you want to solve some economic problems, maybe you need to add more of your economic knowledges and use your wisdom to solve these problems. Yeah.
Yeah, like add more restriction on these actions. This is just a simple example of the CKB contract. We have more complicated like stablecoin logic, but we are not going to talk about today. It's going to take a long time. So what measures are in place to prevent unauthorized use or attack on cells in the CKB system? So we just talk about the lock script, and in our today's example, we replace the lock script with an always success lock script. So it's just that everyone can use your cell, right? But in the actual environment, the lock script will be replaced like a signature verification, and you can use this public key to control your cells. You can only unlock your cells with your signature. Like, well, this is the same with the BTC's approach. How the cell model of CKB for the development of complex smart contract? Okay, cool. As you can see, we just developed a contract on the Rust. on the REST 5 and using Rust. So that basically means you can do everything on CKB, right? Unlike the Bitcoin script, it's not Turing complete, so you can just do limited things of things like verify some signature. You cannot do some other complex logic like looping or decoding arbitrary data on the Bitcoin. But in the cell model of CKB, we can do everything inside the CKB VM. So that helps you to develop complex smart contracts. A main challenge in implementing SUDP in real-world applications. Main challenge. I think the main challenge. So, what are the main challenges in implementing SUDT in real-world applications? I think the contract itself is always simple, right? And if you consider the ERC20, and if you consider the ERC 721, it's always simple. But the contract itself is simple. But besides the contract, you need some UI design, you need some UX design, and what your SUDT means. It's just a meme or some stable coin, or it means some bridge coin. Those things are the more challenging things.
Yeah, and if you want to use the SUDT in some DeFi applications, maybe you need to face some challenges in how to design the pools, how to deploy the pools, and how to design the complex DeFi mechanisms on the UTXO model. And I guess that will be the main challenges when you try to implement SUDT applications in real world because the financial is so complex, right?
Great. So for the next program, bond mechanism ensures that only minting, transferring, and burning actions are allowed with SUDT. Well, the mechanism is what we just wrote, like some code, and you limit that the input amounts have to be greater or equal to the output amount. That means you can only transferring and burning, and only if you are the owner, you can do minting. So that's how we ensure that only these three actions can be done with our SUDT type. And why is transaction classification by type important for access management on CKB? Well, because it's simple, right? It's easy to understand. Similar to Rust, right? And CKB cell model is basically the same as Rust type series. It's the data ownership is owned by a cell, and if a cell is moved, is dead, is involving in a transaction, it can't be used anymore. And the moved data will produce some new data. So it's quite similar to the cell model and the Rust programming language. They are all kind of functional programming pattern. So why type is important? Because it controls how your data behaves. So how these numbers become like some token, not just any kind of arbitrary number, like anyone can mint your token. That's not what we want. We use type to restrict their behaviors. With other tokens of blockchain, is there a mechanism to bridge SUDT with tokens on other platforms like Ethereum? Yes, we in the CKB ecosystem, we already have a project called Force Bridge. It just used the SUDT type we talked about before, and it's like have a light client on our CKB blockchain, written by Rust, and use what we talked just before. You use the Rust language we talked before, and the script runs on the REST virtual machine. and the live client runs on our ZKP blockchain and and it has data from the Ethereum blockchain. So you can bridge some tokens from the Ethereum to ZKP and also bridge back, right? Like we have used USDT token on ZKP. So they are also SUDT, and we have other tokens on ZKP. They are all based on our simple user-defined token protocol, the SUDT type.
Yeah, if you're interested in how can we bridge the SUDT to the Ethereum, you can check the GitHub of the Force Bridge, just as Hansen mentioned, and you can see some implementation of that project. Yeah.
I think I got another question is that how does the SUDT to ensure the compatibility with other tokens or blockchains?
Okay, compatibility with other tokens of blockchain. The SUDT basically like is a standard on the
Mhm.
CKB blockchain, like BRC20, like ERC20. They are just some standard on different blockchains. All of these standards represent a number inside your account. So they are quite similar things. They have same data, but with different interface. So if you want to ensure compatibility, you can just use like uh, typecasting, right? It's a type, so you can do typecasting to transfer one data to another type of data. Hmm. What is the relation between the cell model of CKB and functional programming? Uh, the cell model of CKB follows the functional programming pattern. So as you can see, it follows that the data is immutable. It only transformed to other data. So it's not you are not, how can I say, mutating some data. You're transferring some data. That's what functional programming does. So the cell model of CKE basically do the same thing. How the cell model of CKB improve performance and security compared to the traditional UDX model? Great. Comparing with the traditional UTX model, the cell model basically enables its programmability, helps you to develop smart contracts or script on the cell model. Like as we know on the on the Bitcoin, we can't write smart contracts, we can't write scripts and run them on the Bitcoin. So that's what cell models do, like the programmability. So, but for the performance and security, it's about POW things, proof of work. And the CKB is the same with the Bitcoin. They both run on, based on POW. So that's how we keep the same performance and security with Bitcoin.
Yeah, miners support as security.
Yeah, the more miners you have, the more security your chains become. How do smart contracts interact with SUDTs? The SUDT itself is a smart contract or a script. If you have other types of contract want to interact with the SUDT, first, uh, as we talked about before, this scripts, this smart contracts on CKB is kind of verified. So if you have other verifiers who want to verify the process of SUDT, like let's talk about a simple audible swap. So if you are implementing an audible swap on the CKB, an audible DEX on the CKB, you might want to verify that user A want to trade phi token A for phi token B. So your audible smart contract should verify that in a transaction, the user A, if the user B gives the user A phi token B, then the user B can pay phi token A. Such a thing is just verified. So it's not like interact. It's just like add more restriction to your transaction about how what you can do inside this transaction. That can be performed with SUDT. How do I claim SUDT? So the main action that can be performed with SUDT is like transferring, right? You can transfer your token to others. So if you want to claim SUDT, it depends on the owner, right? Only the owner can mint SUDT. So if the owner decides to build a server, and if you register on the server, they will mint you some token, and that will be how you claim SUDT. Or if the owner decide to mint the SUDT before, and if you meet some requirements, you can call the SUDT. Then you can use the transferring action to claim the SUDT. CKB can share what are the states of sales during a transaction. I'm not sure what this question about. CKB can share what are the states of sales during a transaction. So inside a transaction, you can read every input sales, and you can read all output sales. And you can also add some sell dapps, right? As we mentioned before, sell dapps is like you can't modify its data. It's not moved. It's kind of reference, similar to Rust's reference. It's on the sell depth part. You can read its data, but you are not moving it out, so you cannot transform it or modify it. So that's basically all you can read. You can also read some block header or some witness similar to the SegWit on Bitcoin. That's all inside the transaction. And the verifier can read all this data on CKB.
So for the SUDT, can you show some practical application and use cases that have been implemented using the SUDT?
Cool. For the SUDT, as we mentioned above, we have a project called Force Bridge, and it can bridge tokens from Ethereum chain to CKB so that you can trade this token on CKB. And for the UTXO model, like the cell model, the user own its data. It's not the data is not stored inside some kind of contract, and the owner of the contract can modify it as they want. So it just simply help you to keep your token secure. And also the CKB ecosystem, we recently have the RGB++ asset. The RGB++ asset, you can think is some kind of special SUDT token. And the special SUDT token is controlled by an UTXO on the Bitcoin. So that helps you to use the security from Bitcoin to manipulate your assets on the CKB. And we use other mechanism in the RGB++ asset to help you to issue issue access on the Bitcoin layer 1. And also we have some like CKB inscription similar to the BRC20, and it's also based on SUDT. Right, you can inscribe something on the chain, and you can fair mint SUDT on CKB. What algorithm is used to maintain centralization between nodes in the CKB network? Well, that's not what we're going to talk about today, but the algorithm, you can find the algorithm in the CKB's RFC. And you can search for CKB RFC and you can check them on the GitHub.
By the way, I guess with SUDT, they also developed the UTXO Swamp to exchange their SUDTs or extend special SUDTs. So in the CKB ecosystem, I think SUDT is like a basic, and you can build many DeFi applications on the basis of the SUDT contract.
Yeah. What ERC20 can do is what SUDT can do. What SUDT can do, maybe ERC20 can do that. The user owns the full ownership of the SUDT. That keep the security.
And for the from the developer support side, like, do you recommend any resources or tools that are available for developers who are looking to work with SUCT?
Sure. For the code we mentioned before, we have a tutorial for this, and it's on the Neurostock website. Can I share the link? Can I share the link here, or
You,
where
you
should?
you need to link your YouTube or the Facebook, then you can maybe you can share your screen.
Okay, share my screen. Okay, it's not showing my screen, so Carol, could you please help me to move my screen to the stage?
Sure, let me ask the admin because I do not have the permissions to do that either. So let me ask her.
Okay, you can also search the CKB Eco Fund and find the GitHub. It also has some developer resources, and also you can direct search the Nervous doc, and you can see the link that Hansen just mentioned.
How does CKBU cell
It's
model?
Yeah, it's on now.
Cool. So
Hansen,
how
this
does
is
CKBU cell model algorithm to manage access? It's not the cell model is kind of programming pattern on CKB, and you build your own TypeScript like the SUDT we mentioned before to help you to manage access on CKB. So this is the Nervous Network GitHub. So you can find RFC here. This one, you can read everything you care about inside this repo, like the positioning, like the P2P algorithm, and like the virtual machine, and like the mining protocol. Everything on CKB, you can find it here. Okay. As for the documents, okay. you can find the documents on the, we have a CKP EcoFound organization, and we have a repo called CKP Developer Resource, and you can find everything you want inside here. So you can find all the doc websites and some tutorials and some SDK repos here. And for the SUDT we talked before, you can visit this website, the Novel Stocks, and you can find the white and SUDT script by Capsule. You can read the whole tutorial here. It includes all the codes we talked about today, and it also has other parts I ignored today. Okay. Any other problem? Benefits of SUDT.
Okay.
SUDT is a protocol. It's not some kind of stable coins, like it's not USDT. It's simple user defined token. It's not simple US dollar. So it's not a replacement of stablecoin. It helps you to build stablecoins on the CKB ecosystem. Like the USDT on the CKB ecosystem can be based on the SUDT protocol.
Yeah, and if you're interested in the stable coins on CKB, you can search the stable plus plus, and you can maybe find more information about the stable coins on CKB. Yeah.
Okay. So, and also for another aspect is that with two other like participants for the hackathon, the Vietnamers hackathon, do you have any uh, like advice for them in terms of if they are building a projects including or relevance to other technologies like Rush, ZKPs, and like or SUTT type like that?
Um, if you're gonna do a project on CKB during this hackathon, you can do some simple applications like just SUDT or some more other things on CKB. Like you can basically do anything on CKB, like what you want. You can build a game on CKB, like a simple game like I don't know, trading or just rock scissors paper or something like that. You can do this kind of thing on CKB and experience the sale model and try. I'm not sure. Yeah, this kind of things. SUDT is a standard of token standard on the CKB. So you can do some logic based on this token standard. You can define how it transfers, under what kind of situation it can transfer, or you can stake this SUDT into another contract to do other things like staking or failment or something like that, or launchpad, or you can use the SUDT standard as your like gaming token and some kind of asset. You can use the SUDT to build a simple game based on it. That would be great.
Yeah, I can't agree more. It can support almost all kinds of DeFi applications like the stable coins, the lending protocols. If you're interested in the lending protocols, we I think it's a good choice for you to develop the lending protocols in this hackathon, and you can maybe also try the launchpad or the swap, things like that, uh, based on the SUDT. And besides the SUDT, we also has the Spore protocol. So if you're interested in the NFT related projects, you can just find the resources in the CKB Developer Resources Hub and learn more about NFT based uh, SDKs and tutorials, and then you can combine the sports with SUDTs and develop something like the NFT landing protocol or the game, just as Hansen mentioned before, some games on the CKB chain. Maybe use the SUDT as their token and use the sport protocol to issue the equipment of the game or develop some game marketplace, something like that. So as for the ZK based applications, I remember some other teams have developed a ZK virtual machine for CKB in some other hackathons. So if you are interested in some ZK based applications, maybe you can try to develop something like that. Yeah, so just try to do anything you want on CKB in the following hackathons. And if you have any questions about the developing applications on CKB, you can just ask Hansen and me. And we have another mentor called Arrow 404. And I guess all the mentors and judges will answer your questions as soon as possible. What are the advantages of using Rust over other programming languages when working on CKB? Hansen,
I think it's a great problem, right? So actually, we can use multiple kind of programming languages on CKB. Like you can even write C on CKB, C language on CKB. But for me, I think the Rust is kind of native language for CKB. It's kind of natural to write Rust on CKB. Why? Because just as we mentioned before, the CKB cell model is kind of functional programming pattern. And this other language like C, they use the structure programming model. And like Java or JS or something, they use the class programming model. So class oriented programming model. So for the cell model in the CKB, the Rust functional programming model is suitable for developing on CKB. And also, the Rust is memory safe, so you don't want to have some memory leaking problem on the virtual machine on a non-STD environment, right? It helps you to keep your program safe and you are not making mistakes about neural pointers or something. And it's important while you are developing smart contracts because smart contracts on the blockchain simply helps you to protect your assets. Uh, you won't make some mistakes inside it.
Hanson, can I ask you a question from the slide that you are presenting here? So I'm not sure how can, like for the minting, like from one cell without anything, then minting to the cell with 10 stable coins, like basically like where is that coming from? Like is it from the projects or any kind of, I'm not sure about this.
So the SUDT type is kind of standard, right? So let's consider about the ERC granted protocol on the EVM. So it's like maintain from nothing. There's nothing there, and you mint some token. You create some token for your use case. But the minting process can only be performed by the owner or by the creator of the SUDT. Like if you are using the USDT, then the theater they can mint the USDT, right? If you stake some real US dollar to them, then they will mint some USDT and transfer them to you. Right, that's about minting. If you only care about the blockchain itself, it looks like it comes from nothing. But if you relate the real world with the blockchain, it may comes from something in the real world. Like you stake some US dollar and you mint some token. If you are playing a game and you win again, and the creator might mint some token to you. It's just like some this kind of thing.
Okay, got that. Okay, let me check if we have any other questions. What are the advantages of using Rush over other programming languages when working with CKP?
Yeah, we just talked about
Okay.
that before, right? Rust is secure and Rust is fast and
Yes.
Okay.
Rust is functional programming.
Okay, got that. Okay, cool. So I think like I haven't received any other question left. Thank you for reading all the question for me though. So I think like to I think that will be from the Q&A part. So do you have anything to share to the communities right now?
I find there's more, it's a new question, how to optimize Rust
Oh,
code for the applications on CKB.
maybe yeah.
Yeah, how to optimize Rust code for
Okay,
applications on CKP.
okay, cool.
If you are talking about the compiler things, the CKP contract basically use all tool chains in the Rust ecosystem. So everything you can do with for the Rust code, you can do it for a CKB contract. Right? It's just a plain Rust code, and it will be compiled into a RESTified code, and then the code will be run on a CKB. And if you are talking about the CKB specific things like reading transaction, reading sales, and other things, it's more like verify the verification. You only involve data you need. You don't want to read all sales on the blockchain inside a transaction, right? You only need to involve part of the sales on the transaction. And if you are dealing with multiple transactions, like you want to transfer 3 or 4 sales to others and to different persons, you can do it inside. You can do it in 4 different transactions, not inside one transaction, so that you can run them uh, at the same time. Thank you.
Okay. Okay. Do you guys have any other questions? So you can put in the chat box or under a box on YouTube and chat box in your Facebook platform. Okay. So I think we answer pretty a lot of question already. I think there are a lot of questions and like people really interested about the topic you are sending to. Okay, okay. I think I think I would love to hear some sharing, like if you want to share anything to the communities in case, like about this topic or about like a criteria that you would look for when you are a mentor for the Rush Vietnam Rush Hackathon.
Mm, okay, so about the criterias, maybe we want to see the demos of your project. So if you have good ideas, please just transfer it to the code, and code could tell us the choose. So I think maybe work more on the codes and just understand the CKB, and it will help you develop a better project. And also at initially we set three tracks for the this hackathon. The first one is the DeFi on the BTC ecosystem and the CKB based on RGB++. And second is the game and NFT based applications around the sport protocol. And the third is the Lightning Network related applications like the Lightning Network wallet. So you can develop some projects around these three tracks. It will also help you get higher scores. And if you have developed a really, really excellent project, we can hold a technical review for you, and maybe you can get maybe $20,000, maybe not dollar, it's USDT's sponsor for further development. So maybe you can first focus on these three topics, these three tracks, and just show us the demo. Yeah. Do you have any other comments on these questions, Hansen?
Yeah, uh, I think Saku explains pretty well. And we are looking for makers, right? We are looking for people that can do some contribution to the CKB ecosystem, like build more protocol standard or build more uh, mm, basic application on the CKB, like some swap or some really interesting application. We are not, uh, yeah, meme coins option is kind of good, but we already have enough meme coin in the blockchain, so we are looking for some developers that can do more new things, interesting things to help users to explore the possibility of blockchain.
Yeah, and we are calling the developers for the landing protocol. If you want, if you experience in the DeFi field and have ever developed the landing protocol, I think uh, it will be a good topic for this hackathon this time. Yeah, yeah.
Okay, cool. Thank you. So I think we're about to time anyway. So I think we can wrap it up right now. And yeah, and I think that for the ZKP language is really it's not quite common in Vietnam yet, in the Vietnam developer community. So it's really useful for your information to sharing here to all the audiences today, so they can have more information, insight, and knowledge about this. So it's really helpful. So of course, like if you guys have any questions left, you can just put in the chat box, and maybe I will can ask you guys later and transfer the answers to them. But let's wrap in a nutshell is that we have pretty good topic today with a lot of questions and a lot of interest from the audiences. So thank you, Hansen and Secure, for their supporting for that. And I think yeah, this is it. And we hope to see you guys in Vietnam next week for the Vietnam Rush Hackathon. And uh, we're looking forward to a lot of topics and also a lot of projects on site.
Thanks, Carol. Thanks, everyone. See you in Vietnam.
Okay,
Okay,
goodbye.
thank you.
Yeah. Oh, and one more thing I would like to mention to the communities that we actually we're gonna have a section from Mr. Ling, but unfortunately he has uh, a business that he has to do. So we will arrange another day for his training day later. So thank you for your understanding for that too. Okay. Thank you, Saku. Thank you, Hansen. And I think we should will end the workshop here today. Okay.
Okay.
Bye.
Good night.
Thank you. Bye.